This is sort of, I'm going to be real brief on this, but this is what happens. When you turn your hot water on, you have a delivery. That delivery takes a long time to get your hot water to a usable temperature. If your water heater down here is putting out 120 degrees, here, oh, wonderful, okay. It doesn't show up. Anyway, what happens is this is the water heater temperature that your water heater puts out. So it's 120 here, and it should reach 120. The problem is it doesn't, because your lines are uninsulated, and what happens is your heat loss in your line never allows that water temperature to get to 120 degrees. You're lucky to get it around 115 to 116 degrees because the heat loss in the line. You can't move water fast enough, you have a higher heat loss. This line here represents the water temperature that is usable. That's when you will start using hot water, somewhere about 104, 105 degrees. Unless you're taking a shower, and then you're going to want it to be a little higher. You'll want to be it up here. This line represents the time that you actually use hot water. So what you're doing is when you stop using hot water, you have a huge drop in temperature. That drop of temperature is because that line is uninsulated. You never got it up to a high temperature, so your temperature drops very rapidly. So the usable hot water line and from your existing water that you've reached is a very short distance. It's within 4 or 5 minutes you've lost that temperature. We're able to move that water at a much higher temperature because we're moving it around 4 to 5 gallons. We can get it at 120 degrees to start with. So that line, this use line is the same, but our extension line goes out much further because it's at a higher temperature. So your short uses now will last longer. If you insulate those lines, they'll last a long time. This is a fact. Approximately 10 gallons of hot water coming into your home, or the use of hot water, represents a kilowatt hour. Those numbers have been badgered around by the California Energy Commission, the U.S. Department of Energy, the EPA, but nobody has questioned that that is possibly the correct answer. Now, that doesn't represent just your house. What it does, it represents the pumping it out of the ground, the transferring it, the processing of it. It's a series of things, including the sewage. So it's a combination of everything. But the end result is 10 gallons represents 1 kilowatt hour. What does that mean to us? What it means to us, and this has been proven by the U.S. Department of Energy, that every kilowatt hour represents 1 pound of carbon dioxide, a pound and a half. So do the math. The more you lose, the higher your factors go on your carbon footprint. If we were to save if let's say our average is about 20 gallons a day, 7,300 gallons a year, and we were to save 100,000 homes. Now keep in mind there's close to 100 million homes in the United States that have water heating systems. If we're only to save 100,000 homes, look at the numbers. You're talking about 113,000 tons of carbon dioxide we would save on 100,000 homes. You're looking at 100,000, that's electric. So you go down here and you'd see over 6,000 tons of nitric oxide. So you go down to where it says gas, and on the gas heaters in California we have about 90% of the water heaters are gas, so we have to look at the gas. The gas would represent 5 million therms, 81,000 tons of carbon dioxide. That is per 100,000 homes only. So do the multiplications and what that would mean to our ecological system if we were able to save a lot more. This is a home test that I'm going to run through very quickly. I told you that we had, I sent out 30 homes, bulletins to 30 homes, and we ended up getting 26 of those homes responding. And we called them and asked them why they did it. They said they wanted to learn more about our system. This required them to actually report back to me as to a number of things. I was looking for literally 5 things. This is our pump systems, by the way, so I can show you what it is. This is what one of these systems is what they installed. Each one of these systems represent a higher performance, meaning if you've got a Habitat for Humanity, and by the way, every Habitat for Humanity built in Southern California uses our system, and yet they're only 1,200 square feet or less. Why? Because they recognize the energy and water conservation side. So depending on the pump size, depending on the size of the house. We've done a 18,000 square foot house, a 20,000 square foot house, and we use different pump sizes. Sometimes we zone them so they don't try to make one created big loop, so we go to shorter, maybe 2 or 3 loops. Why should you circulate water in a 15,000 square foot house when typically they're split? You got half of it over here you use sometimes and half over there you use sometimes. So we do it a different way, but those pumps represent what we do. In each system we have an electronic board and we have a sensor. That sensor, and we have a model over there so I can demonstrate it, that sensor does a number of things. The first thing it does when this pump goes in line, that sensor tells the electronic board what my ambient temperature is in my line. Ambient temperature is the water that's standing there you haven't used. That temperature represents both the cold and the hot water side of your line. So if you turn your cold water line on, it's going to be 60 degrees. You turn your hot water line, it's going to be 60 degrees. That automatically registers that number. Why? Because we need a base. The reason we need a base, because we're moving water very quickly from the water heater to the fixture. If you can move that water around 4 or 5 gallons a minute, you can move 60 degree water at 120 degrees in about 2 feet. It goes through the pipe like a bullet. So now that sensor has to do one other thing, because remember that's my cold water side if I'm using my cold water standard plumbing. So I don't want hot water in that side of the pump. How do I do that? Well, that sensor now picks up a change of temperature, a delta T. It has already got a base of 60 degrees. It knows your base temperature is 60. That now shuts off at about a 7 degree temperature differential. It shuts off around 67 degrees. So when I turn my cold water faucet on above that, I got 60 degrees. But when I turn my hot water faucet on, I have 120 within 2 feet because I brought the hot water there and shut it down on a very sharp delta T. Now, I said 60 degrees was your base. It doesn't matter what your base is. That's why we sell this to 7 countries now because we don't care what the temperatures are. That base temperature can be 40 degrees, 35 degrees, 75 degrees. That'll automatically adjust to that temperature. Even during the year, your ambient temperature changes, that automatically adjusts to it. It's got a brain. It's actually a smart system is what we call it. This is the easy installation. You simply pull your angle stops off. We supply the connections. We supply the flex lines. That's basically what you're doing is putting it underneath the cabinet.